All right, let's put ourselves in the shoes of a data engineer on day one of a brand new project. The mission? Build a secure, fully governed data platform completely from scratch. I mean, where do we even start? Well, in this explainer, we're going to walk through that exact journey, mastering all the key data governance concepts you'll need for Section 5 of the Databricks Data Engineer Associate exam. So, first things first, our engineer has to figure out where all this data is actually going to live. And that brings us to a really fundamental choice in Databricks, one that trips a lot of people up: the difference between managed and external tables. And hey, don't just take my word for it. This is a real question from Stack Overflow, and it hits the nail on the head. Why on earth would you let Databricks control your data and risk losing everything if a table gets deleted? It's a fantastic question, and the answer tells you a whole lot about the philosophy behind the Lakehouse. Okay, so the core difference really boils down to one simple question: who owns the underlying data files? With a managed table, Databricks owns the entire lifecycle. That's both the metadata, the table definition, and the actual data files. So when you run a drop table command, poof, it's all gone. But with an external table, you own the data in your crowd storage. Databricks only manages the metadata pointer to it. So dropping the table just deletes that pointer, leaving your precious data files safe and sound. So let's circle back to that big why. Why use managed tables if there's a risk? Well, the crucial point is simplicity and optimization. When you let Databricks manage the whole shebang, it can automatically apply awesome performance boosts like predictive optimization. And when you drop a table, the data is automatically cleaned up for you after a grace period. That means no more orphaned files, no more manual cleanup headaches. You're basically trading a little external control for a ton of convenience and performance inside the Databricks ecosystem. All right, so our data has a place to live. That's great, but there's a huge problem. Right now, it's like a house with no doors and no locks. Pretty much anyone who can get into the workspace can see it all. So how do we start locking this thing down and making sure only the right people get the keys? And this, my friends, is where Unity Catalog really steps into the spotlight. It's so much more than just a catalog. It's our central command for building all the security walls and setting the rules for our entire data estate. Unity Catalog organizes everything in this really clean 3-level namespace. You've got the metastore at the very top, then catalogs, and then schemas, which hold all your tables and views. Now, the real magic here is inheritance. If you grant a team access to a catalog, they automatically get access to every single schema and table inside it. This makes managing permissions super logical and, more importantly, incredibly scalable. So who runs this whole show? Well, it boils down to 3 key roles. You've got the account admin, that's the super user who can create the metastore in the first place. Then you have the metastore admin, who's like the overlord of a specific metastore. And finally, you've got owners at the catalog and schema level who can control permissions for just their little corner of the world. It creates a really clear separation of duties. Now listen up, because here is a pro tip that will save our data engineer from a world of pain. When you start scaling to hundreds or thousands of users, trust me, managing permissions one person at a time is a one-way ticket to chaos. The absolute best practice is to always assign privileges to groups, never to individual users. New data analyst joins a company, just add them to the analysts group and they get everything they need. It is the only sane way to keep things consistent and scalable. Okay, so the walls are up, the access rules are in place, our platform is feeling pretty secure. But how do we actually prove it? How do we know who's really doing what with the data? Who was it that queried that super sensitive PII table yesterday at 3 in the morning? For that, we need to install our security cameras and break out the detective's toolkit. This is where audit logs and data lineage come in, and they provide that layer of transparency and trust that every serious data platform has to have. Let's start with lineage, because this is just plain cool. The amazing part is that Unity Catalog does this for you automatically. Out of the box, it captures the entire journey of your data, from the raw source tables, through all the notebooks and jobs that transform it, all the way to the final dashboards people are looking at. And we're not just talking table level. This thing tracks lineage down to the individual column. And you have to understand, this is an absolute superpower for a data engineer. A dashboard broke? Bam! You can trace the data all the way back to the source in seconds to see what went wrong. Thinking about changing a column in a core table? You can immediately see the downstream impact, every single report or model that will break. It's just essential for impact analysis and for satisfying those tough compliance requirements. And now for those security cameras, the audit logs. This is your who, what, and when for every single action taken in Unity Catalog. Every query, every time someone changes a permission, it is all recorded. You get the user, the action they took, the exact timestamp, and whether it succeeded or failed. This log becomes your undeniable source of truth for any security or compliance audit. All right, our platform is secure, it's trustworthy, it's auditable, we're in great shape. But data isn't meant to just sit in a fortress forever, right? It needs to be used. So what happens when your marketing team needs to share the latest sales data with an external partner? You can't just email a CSV file. That's a total security nightmare. And it creates stale data copies everywhere. So how do you share data without making these risky copies? The answer is to open the doors, but you have to do it the right way. And the modern tool for that in the Lakehouse is something called Delta sharing. Now, Delta sharing is an open protocol, and that is a huge deal. It's designed specifically for sharing live data directly from your Lakehouse with any other organization. And here's the most important part. It works regardless of what platform they use. They do not have to be a Databricks customer to receive your data. The advantages here are massive. First, it's zero copy. You're giving them a secure, live window into your tables without ever creating risky, stale copies. And because it's an open protocol, your partners can connect with the tools they already use, like Power BI or Pandas or Spark. Best of all, every share is governed and audited right through Unity Catalog. Just one thing to keep in mind, remember to factor in potential cloud egress costs if you're sharing data across different regions or cloud providers. And you get flexibility here too. You've basically got two flavors. If you're sharing with another team that also uses Databricks, the Databricks to Databricks model is totally seamless. No tokens or anything required. For sharing with literally anyone else, you use the open sharing model. This generates a secure credential file they can use to connect from any client. It's super versatile. This is all amazing for the data that lives inside our shiny new Lakehouse. But let's be real. What about the data that we can't move? What about that critical production Postgres database or that legacy data warehouse that the business still absolutely depends on? This is it. This is the final, crucial piece of our governance puzzle. To create a truly unified data landscape, our engineer needs to be able to query data right where it lives. And that is the job of Lakehouse Federation. Lakehouse Federation is, frankly, a game changer. It lets you create these direct connections to all sorts of external data sources. We're talking PostgreSQL, MySQL, Snowflake, Redshift, you name it. And here's the kicker. You can query them directly from Databricks without having to move or ingest a single byte of data first. So why does this matter so much? Well, for starters, it lets you create this virtual unified view of all data across your entire organization. You can slash your ETL complexity and costs because you only move data when you absolutely have to. And best of all, you can apply the exact same Unity Catalog governance, access controls, auditing, the whole works, to these external sources. You're basically throwing your big governance blanket over everything. And that brings us to the end of our engineers' very busy first day. In a single day, we've designed a platform that can store, secure, audit, share, and even connect to external data, bringing everything under one unified governance model. So I'll leave you with this final thought. With governance this unified, what data silos are even left to break?